Okay, welcome to lesson 4 of the atoms and particles topic. So this is about how we came to the structure of the periodic table. So what we've done so far is we've looked at different models, how they started off with the atom and then the plum pudding with Thomson and the positive charge, then the nuclear model, all the mass in the middle, electrons around the outside with Rutherford, and then Bohr having the electrons in shells. So that's what we've done in lessons 1 to 3. Then we looked at how we draw these for different atoms. So when we look at something on the periodic table, we can go, carbon has 12 and 6. It's the 6 that tells me that it's got 6 protons and therefore 6 electrons. This is where we got to the end of last lesson. Because it's got 6 electrons, I put a C in the middle. The first shell of electrons could only store 2. The next shell of electrons can hold up to 8, but I've only got 6. So I've used 2 already, so I'm going to put 1, 2, 3, 4. Okay, so this is an example of the work I got at the end of last lesson. So what do I like about this? Clear title. Would have been nice to have a date here. Nice coloured keypad, that's not essential. And then the notes are well laid out. There's the questions from the start of the lesson and the answers. Probably should have ticked those as he went, so then you know. Nice clear diagram of an atom with notes around it and labels, highlighting key words like here, highlighted protons, neutrons, nucleus. Then here's my example that I went through, and then here at the end there's a drawing of the sodium atom. Correct? It's got 11 electrons, which means it has 2 on the first shell, then 8, and then 1. And then this one here, the carbon atom, just one I've just drawn, 2 on the first shell, 4 on the outside. Nicely laid out, 2 pages of work. That was done all within the lesson time. And you look at this and you think, right, when I come back to this in the future and I need to revise it, absolutely brilliant, really clear, really great for teaching himself in the future. So sort of use one example, and I'll try and use different people's each time if it's good enough. So please try, and then send me those photos of the work. And now on to the questions. So you're going to pause now, and then you're going to have a go at these, and when you've finished, press play and we'll go through the answers. Okay, pause now. Oh, don't forget, you should write the question and the answer. Okay, so you're pressing play. Go through the answers, please. Give yourself a tick. You can always email a question in if you're working remotely. Remember, the electrons are in shells orbiting. Different chemicals joined together is a compound, like methane, the example there in the question, because it's carbon, an element, and hydrogen, an element, but there's 4 of them, and because carbon and hydrogen are joined together, it's a compound. Elements joined together. Okay, so John Newlands, and this is again back to thing, about the same time as John Dalton, Newlands and Dalton and other chemists at the time started listing the atoms, and they tried to put them into some sort of order. So this is the first ever attempt at a periodic table, and he started off with the lightest one, and then the next heaviest, and then the next heaviest, and he lined them up like that, and he had 7 groups across the top here. 1, 2, 3, 4, 5, 6, 7. So he had 7 groups across the top, and he filled it up, and then he went back to the start of the next row. Now, it turned out that some good things about this was lithium is a very reactive metal that reacts very quickly and burns in water. So does sodium, so does potassium. So actually these ended up, and they were very, very similar, and that's a good thing. However, hydrogen is not like fluorine or chlorine. So actually, in those terms, that's a bad thing. So from Newland's first lot of work, what was good about it? Well, what was positive about it? He gave an order to what we knew existed. He tried to put them in a table so that all scientists could use the same information. He had some attempt to put them into groups based on the fact they were similar. But, go back to that bit I crossed in blue, not all of his worked. And what he did was he made a fundamental mistake. So what was his fundamental mistake? His fundamental mistake, very easy, he didn't leave any gaps. He shouldn't really have put this one in here. He shouldn't really have put these here together. These are good. As I said before, these are good. But actually what he did was he made a few silly mistakes. He just didn't leave any gaps. He thought, we know all the atoms so far. And actually in those days, back in the 1800s, they didn't know them all. So what I'd like you to do very quickly is just write down, here's his name, John Newlands. He was, what you need to know about him, he was the first person ever to do a periodic table. He put them into a table, into an order, and he tried to group them similar, but the bad thing he did was he didn't leave any gaps. When you've done that in your notes, press pause now, and when you've done that, then carry on. Okay? So, then the next scientist to look at it was Mendeleev. And Mendeleev, here's his group 6. Find my pen again. It's too narrow. I just have to change my pen. Actually change the colour. Here's his group. Oxygen and sulfur together. Fluorine, chlorine, bromine, iodine together. That's a great group. They all behave in a very similar way because of the way their electrons are arranged. They behave in a similar way. And look what he's left. What was his big improvement? He left gaps. Because what he realised was we've not discovered. That's a D on the end there, sorry, that's the worst D I've ever seen. We've not discovered all the atoms yet. So, if we haven't discovered them all yet, he left gaps in it to fill them in later. Because instead of putting bromine, he could have done this, he could have put Br, bromine in here to fill it up. But he didn't. He realised bromine needs to go in this group because it behaves in the same way to fluorine, Cl, chlorine, bromine and iodine. It behaves in the same way to these, so he knew that actually it better suits being in here. He didn't just assume he knew everything. So again, pause now, put a little mini title, Mendeleev, and just explained he improved the periodic table by leaving gaps and putting things in similar properties. Those 4 things in here are all very similar. Similar properties. Okay, and when you're ready, then unpause and move on. So, how did they even start to put things in a periodic table, and how are they arranged? So, it's very easy. This atom has 1 proton. and it has 1 electron. It has a mass of 1 because it's only got 1 proton, no neutrons, and it has an atomic number of 1. And on your periodic table you will see it is called hydrogen. It is the first thing on the periodic table. Its atomic number is 1, this number here. Draw a little arrow to make sure it doesn't look like a negative sign. So what's next? Well, what's next is helium. And helium has 2 protons. And it has 2 neutrons. So it has a mass of 4 because you add the 2 and 2 together. So I'm going to write P, P, N, N. So that's why the mass is 4, 2 neutrons, 2 protons. Because it has 2 protons, it has 2 electrons. And there we go. There's its 2 electrons. And then that shell was full. That is the first period of the periodic table. When you look at your copy of the periodic table, you've got a box over this side which should say hydrogen, and you've got a box over this side that has helium. Then underneath that, so that's group 1, this is group 2, this is group 0 or 8, and then we've got 7, 6, 5, 4 and 3, and then we've got others in the middle. But for now all we're interested in is this next level down of the periodic table. Taking me a while there, sorry, I had to concentrate. And what I'd like you to do is the next one down is Li, lithium, because it has the number 3. So far we've got 1 proton, 2 protons, 3 protons. It's got a mass of 7. Hopefully you'll be able to work out, so 3 protons, 4 neutrons, that makes 7. Fill that line in. Right, what I'd like you to do is, for lithium, I'd like you to do this. Li, it has 3, so it has 2 in the first shell, 1, 2, and then it has, hold on, I had 3 in total, so I've only got 1 left, 1, 2, there's my third one. There's lithium finished. I would like you to do the same now across the whole of this row. And then when you've done that, unpause, press play. Okay, have a go at that now please. Draw them out, remembering you can fit 2 into the first shell and you can fit a maximum of 8 into the next and 8 into the next and then 18. But you've only got small numbers anyway. So your next number here is going to be 4 and then 5, 6, 7, 8, 9, 10. Okay. And then unpause when you're done. Right, what did you find? I know what you found. You found that this one, lithium, that I did, has 2 in the first shell and then 1, and this one had 2 in the first shell and then 2, and this one had 2 and then 3, 2 and 4, 2 and 5, 2 and 6, 2 and 7, 2 and 8, and that shell was full. So then I had to come down to, let me just change colour pen. Come on computer. Then I had to come down to here and work my way across this row, filling up the next shell. And then down to here, filling up the next shell, and so on and so on. So what we end up with is, and these are the 2 things that you need to write about the modern periodic table. and I'll go for different colour pen. Number 1. That's not a different colour pen, that's the same. This should be different. Number 1. How are they arranged? Well, these things here, these columns, are called groups. Groups all have similar properties. Everything in group 1 has 1 electron on the outside shell. Look at it, 2 and then 1 here. Sodium, the next one down, 2 and then 8 and then 1. 2 and then 8 and then 8 and then 1. As you go down group 1, because they have similar properties, because they have similar electron structures. So number 1, these columns, like this one here, that's called a group. Number 2, second thing to write about the modern periodic table, these across a row, that's called a period. So periods, as you go across, the number goes up by 1 each time. You're adding an electron each time. This one here, 6 protons, 6 electrons, 7 protons, 7 electrons, and look at it all the way down the table. Here is 77 protons. I'll try and change colour again so you know where I'm looking. Here is 77 protons for iridium. That means 77 electrons. That means I'd have to fill up the first shell, the second shell, the third shell, the fourth shell, the fifth shell. I'll be into the 6th shell if I was trying to draw that out, but we don't have to do that. Okay, could you please now you've got some notes about Newland's table, then Mendeleev's improvements, and in the modern table we've got rid of the gaps because we think we've found everything, because we've got better techniques now and more evidence. And groups like this group have similar properties, and periods like this period, you work across, adding 1 and filling up a shell. So you've got a few notes there to write about the modern table, please. Then unpause and move on. Why has it suddenly appeared that one lot of it has gone yellow and one lot has gone white in the background? This red line here, could you draw that onto your copy of the periodic table? And then could you label this side of it metals and the other side of it non-metals, and then move on. So that's just the same again. Those are the groups, those are the periods. Keynotes, and I just put this at the very end of the lesson so that you can look at this and go, right, atomic number, yeah, I got that, that's a small number, it's the number of protons, that is in an atom is equal to the number of electrons. The mass number, that's when you add the protons and neutrons together because they weigh 1 each. So to work out the number of neutrons, here is your total protons and neutrons, the mass number, and all you do is you take away your protons, your atomic number, and that will give you the number of neutrons. Can you just make sure those notes, oh, the sun's come out, can you just make sure that those notes are really clear in your book? And then you're done for today. Thank you.